Welcome to Tech Talks. Our talk today is focused on cloud data modeling for security. Tech Talks is a series of short webinars focused on features and best practices within use cases. We value you, our customer, and want you to continue in your Splunk journey. Our experts help create these tips and tricks, and we want you to leverage them in your daily role. I'm Renita Datta, a product marketing manager for the Splunk platform focused on our cloud offering, and I'm excited to share with you information about how you can build a unified cloud data model in Splunk, and introduce my colleague, Rod.
Yes, thank you. My name is Rod Soto, and I work with Splunk Threat Research Team, and I'm happy to talk to you today about security cloud data model.
Thank you, Rod, and you'll hear more from Rod soon. Today we are going to talk about what are the challenges in adopting cloud platforms, how can Splunk help, then Rod will walk through a demo of the unified cloud data model, and we will cover some additional resources available. Our team will be available for Q&A throughout over the Q&A feature. And if you watch a recorded version of this webinar, please continue the conversation through the Splunk community website for any follow-up questions. Stay tuned for a few poll questions at the end to get your feedback. Cloud is a key enabler of transformation now more so than ever. Over the last couple of years, the conversation has moved from should we move to the cloud to how do we do it in the right way. Because although cloud adoption is pervasive, it adds a lot of complexity and gives rise to significant challenges. Let's see how. Cloud technology changes and evolves at a very rapid rate, making it difficult to achieve end-to-end visibility at all times. The cloud platforms you build your apps on are not your systems, and it can be unclear where the line of security responsibility lies. This can often lead to misconfigurations. Modern app dev teams follow a DevOps culture, focus on releasing code faster and build with more complex interdependencies, causing unpredictability and risk. Lastly, vendor competition and different standards are not helping create a clear and unified vision. There is no industry-wide accepted framework to follow. All right, let's go one level deeper into these challenges, and I'll hand it over to Rod to speak to what does this mean for you as an admin, developer, architect, manager, or analyst working with cloud platforms.
Sure, thank you. So as Renita explained, there are several challenges that are presented with this cloud transition and adoption of different multi-cloud platforms. So some of the main challenges consist of it requires knowledge of data workflows in generating technologies, the data that's being generated. It requires storage and flow of data to an entity to an outside vendor. This happens because all vendors, they sort of take the position of they don't want you to take the data away from them. They want to keep it there, and they want you to use their tools. And when you take this to an outside entity, this entity must be able to process, store, index, and analyze data. This data is by nature disparate between vendors and needs to be normalized. So what we've done in Splunk is basically research and come up with 6 categories that move across all vendors, normalize the data, and allows the customer to have a single and unified visibility when it comes to mainly 6 categories. Those categories are compute, network, database, storage, management, and of course, security. In compute, we talk about VMs, containers, apps, microservices. On network, we talk about traffic within cloud networks, inbound or outbound to the internet. Your database, which is usually a SQL or non-SQL, your storage, which will comprise some sort of a bucket or some sort of a related storage. Management, which is basically some sort of a Kubernetes flavor, your login setup and your management access. And in security, we have heavy emphasis in identity access management, encryption, and firewalls. So these 6 categories pretty much apply to every single vendor. Okay, and with that said, we're gonna now take a look at how this looks in action. Let's take a look at a demo.
So first, we had to download the add-ons for the data model. As you can see right now, this is the Microsoft Cloud Services one. So the Microsoft, when you had to go to splunkbase.splunk.com in order to download the add-ons for this specific vendors. So in every single one of them, there is an explanation and overview, a release note, if applicable, and a version. There's also details where you can find more information about how to set it up, specific fixes and configuration that you may need to apply. Here's another example, which is the Splunk add-on for Google platform. And in this one, again, the logic is the same. You have the overview that tells you exactly what it does and how it does it. You have the details, the release notes, the version of it, and you're going to need this in order to ingest data from the different cloud vendors. In this case, specifically, is Splunk Google Cloud Platform add-on, and finally, the Amazon Web Services, which is obviously the most popular web platform for cloud services. And in this case, we have a number of items where they explain to you the things that you can get from this add-on, where you can get documentation, the requirements for this add-on, and finally, we want to go to github.com/Splunk/cloud-data model security-research, where you're going to find the actual data model. In this data model repo, in this GitHub repo, you're going to find the cloud infrastructure data model, where you're going to see the details of the source types we ingest. You're going to see the features of the cloud data model. You're going to see the mappings, the basic mappings that we have, things such as activity VMs, how you can put source types to features. Again, going back, you can do Google GCP pops up message, MCS :Azure :audit. There is definitely a procedure per cloud vendor, per source type. That's something that you're going to have to do on your own. If you need help, please feel free to reach out to us at research department at Splunk. But definitely, in order for you to use this, besides the add-ons that we just went through, you're going to need a number of steps in order to get this data ready to go. As we went before, the prerequisites are there. It tells you how to install the data model. It tells you, in some cases, you may have to move the props.conf, the tags.conf, and modified events types.conf in order to create the appropriate files for the data model to work. And once you have the source types and the data model installed, and the source type data common in your Splunk instance, you should be able to start testing. And when we say start testing, is basically we can do awesome things such as look by the categories that we previously mentioned in this talk. One of them is compute, and then we'll give you a table, a nice table of all the vendors that you have in your environment based on compute. And it will give you other information. You can do it by source type. You can also do it by vendor. if you only have one vendor, for example. And let's go for some examples here. If we go into one of our research instances, you're gonna see I'm just gonna copy this and basically paste it into the instance where we have the data model. So we go and select all time for demo purposes. And as you can see, pretty quickly, we're gonna start seeing data. So the data obviously will come depending on your biggest source in terms of size, meaning what is the vendor that you're getting the most data from. So in this case, we can see how we have compute accounts, compute actions, compute destinations. We have things such as event names, for example, terminate instances, user agent. The user agent is very important when you are monitoring cloud environments because it tells you, does this come from an SDK, for example, API? Or does this come from another type of environment or application? You will see if the actions were successful, the type of instance, the ID of the instance, the region, which is pretty important as well, and very important, the actual source IP addresses where these connections are coming from. As you can see there, we are looking at AWS, what's called ARN, which is the actual account. The status of such request, the user type, the computer vendor, obviously Amazon Web Services. So here's, let's take another look at some of the other data that we can get. We just saw a compute table, but we can now take a look at a specific source type, just for the sake of an example. So we're going to go in again into our instance, and we're going to paste the search, then hit search. As you can see, we're looking at CloudTrail, but we can also change it by another source type, which in this case is going to be Google, and Google GCP is the data that we're about to see. We're about to see basically a table, as you can see, but first we saw it on AWS, and now we're seeing it in Google. The reason why I'm doing this is basically because when you mix all of them together, you will see obviously first the vendor that you're getting the most data from and faster, right? So that is something that happens in Splunk when you have multiple source types within a single index. In this case, what I decided to do basically for demo purposes and to show you in case you just have a specific vendor that you can actually search by source type. In this case, we use source type by Google, and then there it is. There is our table with exactly the same fields, the same information. Remember, we're trying to normalize data across the three providers. That's the purpose of this data model. And we can also play with other type of searches. We can use a very popular analyst command within the Splunk engines, which is tstats. And we can keep playing with our instance where we have data from the three cloud vendors. So in this case, we're looking at statistics that will give us, for example, the region, the vendor, the machines that were accessed. Notice that you have two vendors. You have a cloud, Google Cloud, and you have Amazon Web Services. So you're able to see again the three vendors in one single interface, and that's what we aim for. Get you a unified visibility of all environments. Can you manipulate individual vendors' data with this? Yes, we just show it. Continuing our journey with the cloud infrastructure data model, I wanted to talk a little bit about the practical applications of using the cloud data model and why it's important to search other aspects of our content delivery, such as SEU. So we usually provide updates and new analytic stories, basically on a monthly, sometimes on a weekly basis, depending on the threat landscape and things that we're researching. So in this case, we will be focusing on containers, and in this case, we're gonna actually look at an example of a analytic story, which you go into ESEU, you select keyword search, and in this case, we place container, and in this case, we're gonna look for a detection search in an analytic story that has to do with container implementation. Container implementation is important because if you have a development department that they're uploading containers or using containers, it's important to monitor what they are loading, where are these uploads coming from, is there a possibility that there are backdoor containers that are being uploaded to your repository, and this is defined within the MITRE attack matrix as container implantation. And if we take a quick look at MITRE, which is the leading company when it comes to TTP nomenclature, there is something called the cloud matrix, and the cloud matrix is one of the things that we use to develop content. So in this case, we're going to be looking at container implementation, and container implementation, as I highlighted previously during this demo, it's a technique, within the cloud matrix, which is defined as T1525, and is under persistence, where a container is implanted with a backdoor, and an attacker has been able to either access your keys or get access somehow by an exploitation and upload a container with a backdoor. So we created an analytic story that allows you to detect and investigate if such thing may be happening. So in this case, we do have it. It's called new container uploaded, and basically you search for it. In this case, we already had a demo data on it, and you will be able to see, for example, that it shows up. This is a specific container that was backdoor with a Chrome task that sent an outbound shell. And you can look at this by the image ID, by the source user. You can look at the regions. You can actually look by the source IP where this is coming from. So these are things that you can take a look at, and you can follow up as a way of trying to detect if you have a private container registry, or where you have developers pretty much uploading stuff that may be backdoor. So one of the things that you can use with the cloud data model, and this is something incredibly cool, is you can use, for example, the data from Kubernetes in this case to capture malicious scans, suspicious scans from the internet. In this case, basically, I use the Kubernetes Spire of the cloud data model, added an operator for zgrab, which is a popular tool to scan the internet and get banners and detection of applications. And I simply placed the search term and created a quick table using the cloud data model that told me the source IP, the source user, the action, the Kubernetes action, the destination, the status, and the vendor. And watch how I was able to find that both of our environments were actually being scanned. One of the things that you had to look at in this case is, from the user perspective, is system anonymous or unknown. And obviously you want to know, you want to see that there is actually, the status is usually failure or forbidden. And very importantly, you want to see a destination, because the destination will usually show you a URI strings, paths, or directories that these scans are coming from the internet. Remember, we're also giving you the source IP, and many times you can actually apply further investigation of this. You can do a who is, and mainly basically port it to, for example, a IP rep database. So these are ideas and things that you can do when you're doing detection of scans from the internet. And the cloud data model basically, in a very quick fashion and manner, allows you to discover this.
Great. Hope you were able to enjoy the demo and see how you can use the cloud data model, infrastructure cloud data model. It can have many uses, including detecting threats, looking at management information, things such as traffic, authentication, compute resources, and several other important information points that you can see and you will be able to act on once you apply it to multi-cloud vendor environments. I wanted to give you a little more information about the cloud data model. First, the code repository, which is github.com/cloud-data model-security-research. We also have a blog where you can see how we can detect container implantation, which is MITRE technique T1525. And you can see in action how we're able to detect an implanted container with a backdoor. And then we also have a video of the DEFCON 27 at the Cloud Village, where myself and a colleague, Jose Hernandez, we're able to put together a presentation where we use Splunk to basically audit the entire security posture when facing multi-cloud environments. And with that in mind, I'm going to pass it back to Renita.
Finally, don't forget that we have an incredible community of Splunk users on our community website, where there is a Q&A section. Additionally, you can search for or start a new discussion thread on cloud data modeling, as well as check out Splunk Ideas, where you can submit new product enhancements. To wrap things up, we have 2 survey questions that I will walk you through to help make sure this was a helpful conversation. Were the details presented in this tech talk appropriate for your level of use with Splunk? What other tech talk topics would you like to see presented? We really appreciate you taking the time out of your schedules to join us today. Please tune back in for future tech talks. We are excited to share the series with you.